Construction of finite automata. Regularly, if you see that if you are having any language statements, those language statements has to be given in a mathematical form. So that mathematical form is called as, or mathematical model is called as your finite automata. So based upon this, we have seen the introduction about your about the finite automata, how to work on with the states. Already we have seen a topic regarding it in our previous videos, and now we can start working on with how to construct a finite automata. So this actually begins in a way like it is the first question where we can able to understand all possibilities of having the basic knowledge of making the model. Okay, so in this case, if you see here, to construct a finite automata, the basic question what I have chosen here is to you have to create a model or you have to construct a finite automata for set of all strings whose starting letter is found to be A over the alphabets A comma B. So this is the question. So our sigma contains A comma B, and our string here what it indicates that it should always starts with A. So based upon this question, if you see, let us create our finite representation. Before creating our finite representation, we should understand the question, what it actually gives a basic knowledge about the basic knowledge of the question is actually needed. So based upon that, based upon the question, the string is going to start with A over A comma B means our sigma value is found to be A comma B. So under language, what it says is that the string should start with A. So what and all possibilities our string can able to develop it is like, let us see the thing. So our string can contains the letter A, or it can contain a string called as AA. It can also contain string A followed by B. It can contain strings, which means A can be followed either by A, or it can be followed by B, or it can be followed both A and B. Here in this case, if you see, the string is for A is followed by A, here A is followed by B, here A is followed by any number of B's. That is what it indicates. Third, the next statement, if you see, A is followed by B or A, which means that A can be followed by any number of B's or A's. So this is how our string actually looks like. And our language contains all these set of valid strings. That is A can be followed by A, B, or any number of A's and B's. And we should understand what our string should not contain. So based upon that, our string should not contain B. Remember that our string should not start with B, or any strings that is followed. That is initially, if you see our string, or in all these cases our string contains, it is starting with B. Ultimately it shows that the string is invalid, but B can be also followed by any number of A's or B's. That is what the next set of string it actually indicates. B can be followed by B, or B can be followed by A, or B can be followed by AA, or B can be followed by BA, any number of B's or A's. So whatever the string, this set of strings should not be validated by our automata. So based upon that, let us see how to process with the solution on creating a mathematical model for this particular finite automata for this particular question. So let us start with our start state. So start state, as said, it is like it should start with arrow with a single state. This is called as the state representation. We can represent it as Q0, Q1, or we can represent it as capital A, B, whatever terminologies we want, we can include here. Okay, so the start state, this is how our model is going to start. So it contains a state with an arrow which indicates this is the start state. So based upon the given input, the string is going to, if the string is going to start with A, ultimately the string should get accepted. So if the string is going to start with A, it ultimately it enters into the accepting state. So I'm creating the next state. The next state is an accepting state. So accepting state is represented as double circle. Start state is represented as a single circle with an arrow, and accepting state is represented as double circle. So the control enters into Q1 when the string is A. So if a letter is A, ultimately it indicates that the string is getting processed. Okay, but we have many other constraints. We have to see what and all the other constraints we have in the question. A can be followed by any number of A's. That is one of the constraints, which means that string is starting with A. After A, I can have any number of A's. So the basic diagram we have already made over here. So if it can be followed by any, now the control is at this Q1 position, which indicates that after A, I can have any number of A's. Though if it is reading any number of ways, the string is accepted. So accepting state is present at which state? Q1 state. So any number of A's is represented with a self loop, which indicates after A I can have any number of A's. Ultimately, any number of A's will be accepted, will be getting accepted. So it is indicated with a self loop. So this entire diagram indicates that already A is entered into the accepting state. After A, I can have any number of A's which is represented with a self loop in the accepting state. Okay, so this is one of the condition that is present in the given question. What is the second condition? What we can able to observe is A can be also followed by any number of B's. That is the second observation what we are going to consider. So same set of diagram we are processing it. A, which means that this diagram represents string is starting with A, it enters into the accepting state. After A, I can have any number of B's also. That possibility is also there in the question. So what we do is that instead of self loop with A, now we are introducing self loop with B. So this indicates that after A, I can have any number of B's. This B indicates 0 to n times. It represents the numbering from 0 to n times. Here if you see B value is 0, this indicates B value. Here if you see in the set, B value here is 0, here B value is 1, here B value is 2, here B value is 3. So based upon that, here B value is nothing, here B value is 1, here B value is 2, here B value is 3. So ultimately, this entire self loop, what it indicates that you can read B any number of times. You can read B any number of times. Fine. So so now you have to clap on both the conditions. What is both the conditions? A is followed by any number of A's and B's. That is what the string is getting started with A. After A, I can have any number of A's and B's. That is what the actual question is. So the same set of diagram, we are processing it, but we are introducing both A and B in the self loop, which indicates that after A, I can have any number of A's and B's. So this particular A comma B indicates that after A, I can have any number of A's and B's. So this is your basic finite automata diagram. So from this diagram, what we can infer is that we have 5 different tuples as per the definition of the finite automata. So the finite automata, what it indicates is that it contains finite set of states and it contain where the control moves from one state to another state based upon the input symbol. So it contains 5 tuples. So the 5 tuples is that capital Q summation del Q naught as well as F. Capital Q sigma del Q naught as well as F. So Q represents finite set of states. That is the states whatever we have introduced is called as the finite set of states. Sigma represents finite set of input symbols. So what and all input symbols that has been given in the question is called as the finite set of input symbols or the symbols what we have introduced in our particular answer. This del represents the transition function, how our control is going from one state to the other state is called as, and on what input symbol our transition goes from one state to the other state is called as the transition function. Ultimately, Q naught, it is the initial state. This can be any representations based upon our preferences. And F represents the final state, which can be also called as the accepting state. Usually it is represented as all the double circles are called as the accepting states, or it can be called as the final state. Okay, so let us see how this 5 tuples map to the given question. So if you see here, this is the actual answer we got from our previous step. So here we have to identify what is our capital Q, what is our sigma, what is the del, what is Q naught, and what is F. So based upon that, our capital Q is finite set of states. That is, you have Q naught as well as Q1. That is, Q naught as well as Q1 are the finite set of states what we have here, Q naught, Q1. So what and all input symbols we have processed here? One is A, another input symbol is B. So the input symbols what we are processing here is found to be, the sigma value is found to be A comma B. Next thing, it is like it is sigma. After sigma, it is your transition. So before transition, let us see what is the start state. Start state what we have here is found to be the Q naught. Okay. Then the accepting state what we have is found to be the double circle Q1. So that is called as your final state. Next thing what we are going to process, it is your transition function. This transition function basically we can represent it in terms of table, which is very easy to understand. So the table contains state bar input table. The table what we are going to draw, it is called as the state bar input table. So towards horizontally, it contains the input symbols whatever we have introduced. What input symbols we have here? A and B. So the input symbols what we have introduced here is A and B. Next comes the states. What and all states we have here? Q naught as well as Q1 are the two states that we have introduced. Okay. Now how we are going to make this transition table is from Q naught where your A transition goes. From Q naught where your A transition goes. From Q naught A transition goes to Q1. So ultimately the transition here is found to be Q1. Again from Q naught where your B transition goes. From Q naught is any B transition? No. So ultimately it is nothing. So we have we have filled it as empty. Okay. Now from Q1 where your A transition goes. From Q1 your A transition goes to Q1 itself. Okay. Next from Q1 where your B transition goes. From Q1 your B transition goes to Q1. So this is called as the transition function of your entire transition diagram. So this diagram is called as the transition diagram. These are the 5 tuples of the transition diagram and this represents the transition function or transition table for the entire sequence. Okay. Next thing what we are going to process is like here Q naught with B, it indicates it is nothing. So this always remember, like you have a definition of your finite automata where um, every transition should have some input symbols over, that is every state should have some transitions over here. It should not be null all the time. So if that was the thing, then it is called as your deterministic finite automata. So in upcoming thing we can learn how this DFA actually going to work on. So but we have another constraint where we understand that if your string is going to start with B, it should not get processed, right? So, say another thing, it is like you see here, you have an arrow mark which represents the representation of start state, and you have another thing, it is a representation star represents the accepting state. Okay, but in the question we have another thing, what it indicates that if the string was going to start with B, it should not get accepted. So we have to process with that sequence also. So if the string is going to start with B, ultimately what it indicates, it is like, see here, we are going to introduce another state, that is Q2 is the other state. If the string is going to start with B, ultimately it enters into this state. This state is called as the dead state. What the state indicates is this is called as the dead state. Why we are introducing this dead state is if someone is trying to process the entire set of your set with trying to automate or trying to validate this particular automata diagram with the input string B, it should not get validated. So it should not get validated in the sense the string should not get accepted. To understand that if the string is going to start with B, it should not enter into the accepting state. So I'm introducing a dummy state that is called as dead state, which indicates that if the string is going to start with B, it enters into this dead state. Okay. So this dead state cannot be an accepting state at any case. Then another thing is that if the string is starting with B, B can be followed by any number of A's and B's, right? So the B is going to followed by any number of A's and B's. Ultimately, it should not also get accepted. It should not also get processed. So if the string is going to start with B, B can be followed by any number of A's and B's. That also should not get accepted. So we are introducing a self loop at Q2 where we have a transition of A comma B over here, which indicates after B I can have any number of A's and B's will also not get accepted. So to the entire thing, if you see this particular sequence, this particular entire thing, what it says is that the string is going to get processed and the other thing going to get accepted. The other thing what it says is that the string is not going to get accepted. So this is the uh, for this is the basic question of generating your automata diagram, that is constructing of your finite automata for set of all strings whose starting letter is found to be A. Fine. Thank you.